Well, good day, viewers. Today we have a 2007 F250 Super Duty. I imagine it's got the 6-liter V8 diesel, and it's here because the check engine light is on. Now, the customer says it runs fine, but I noticed when I fired it up that it had a knock in it, and to me it felt like it was misfiring. So we're going to set the scanner up here this morning and have a look at what fault code it's generating. And then we'll fire it up and have a look at misfires and cylinder contribution. Okay, I'm going to try and record this. I'm outside. Normally I'd be inside, but I don't want to start it up cold and see how it runs. It should support automatic ID. Key is on. Yeah, automatic ID and the mileage retrieval. I'm going to go straight into engine controls because I didn't want to do a key on engine off test. I hit the button twice. I just want to do memory codes and see what kind of codes it's got. Oh, continue. Cylinder 1 injector circuit low. Cylinder 2 injector circuit low. Cylinder 3 injector circuit low. Kind of starting to look like a fuel injection control module problem. 1, 2, 3, 4, 5, 6, 7. Wow. Fuel injection control module performance. And cylinder 8 glow plug circuit. Well, if cylinder 8 glow plug doesn't work, that could constitute a misfire. But when I started it up, it had a miss and a knock. And the injector would do that, or the glow plug would do that when it's cold. So let's have a look at some data on a cool start. Misfiring glow plugs. I'm going to record this data and then I'm going to drive it in the shop. Cycle the glow plugs again. Definitely got a miss in it, but it's not showing misfires. At least I can't see it in this. Okay, I'm going to bring up cylinder contribution test here. Power balance test here. Maybe we'll be able to see a misfire on here. Definitely got a knock in it, but it doesn't seem to be missing. Not according to that, anyways. I'm going to bring this inside. We're out of the light, out of the sunlight here. So let's look at a cylinder power balance test. I think the miss that I felt was because of one glow plug not working. It's certainly not misfiring now, and it's not knocking like it was when I first started it, and that was probably just because the one cylinder wasn't firing correctly. So I'm killing injectors one at a time. So all the injectors are currently working fine. Well, no point doing a cylinder power balance test here. Well, we did have a number of codes related to the FICM. That's usually, you get all those codes usually when you have the FICM failure, but it usually doesn't run. I wonder what the FICM voltage is. I think it's 48 volts it's supposed to be, if I remember correctly. 13.5 volts to it. 33 volts, that seems low. To me that seems low. If I remember correctly, it's supposed to be 48 volts. But let me do some checking. So in the pinpoint test for the P0611, it says, are any other DTCs present for DTCs P0261, 64, 67, 70, 73, 76, 79, and 82 all set together? Go to S2. Key on, engine off, access the FICM and monitor battery positive PID. So we're going to have a look at this. So basically it says if all these codes are set simultaneously, which appear to be, that's the vacuum pump running. It says check the system voltage. So I've got the diagnostic suite open here now, and we've got 13 volts. I've got a clean battery charger. Notice the FICM power is 48 volts now. When it was running, it was like 32 or 33. So I'm sure this FICM is going south. But nevertheless, just looking at the troublemaker chart here, it says check the battery power and the FICM power, which we have. There's FICM MLP, LP powered 13 volts, and V power 13.5 volts. Says if they're all good, go to S10. S10 right here. It says that it fires the injector for about 20 seconds after the ignition is turned on, and they do that. Is the voltage greater than 45 volts during the entire duration of the last 10 seconds? So I'm going to simulate that by going back into the diagnostic suite, exiting out of here, and going into an injector buzz test, and watch the FICM voltage while we do the buzz test. Functional test. Key on, engine off, injector, injection control pressure, duty cycle. I wonder if we can see this voltage. Let's try this. No, we can't see it. We can just hear it. You can hear the injector going through the cycle. Let's see what happens after we do this self-test. Maybe it'll set a fault code for low voltage or something. Not sure how long this is going to take. I'm hoping the camera is picking up the sound of the injectors clicking. Yeah, that's what I thought. Well, let's have a look at data while it's running. Drivability, continue. So it's 48 volts now, but what does it do when it's running? 39, 38, 36, 35, 34, 35. Alright, so this thing looks like it's going to get a fuel injection control module. I'll look at some case histories and see if that's a common failure mode. So you can see the FICM voltage is fluctuating. It's hit as low as 30.5 and now it's running 34.5. These FICMs can be repaired if it's the second design. You can change just the transformer inside, I imagine. But I have to find out whether it's got the first design or second design. We call it a half shell replacement. So this is where the FICM lives down here, and I had a look in there, and it looks like we've got some acorns strewn throughout this engine. Definitely a fire hazard. We'll have to get these acorns out of here. Man, they're everywhere. But I don't think that's got anything to do with our problem. That little cover, where is it? Right there, with the two torque screws on it. I'm going to try and remove that to see if this is a first gen or second gen. So I had to take the air induction system out of the way and the air filter out of the way. Air filter needs to be serviced anyways. I did pick out some acorns, but there's still a bunch more in there. And you can see with that cover removed, two T20 screws. There are 4 pins on this fuel injection control module circuit board. So that apparently is the style that can be repaired by simply changing the transformer in there. So we're going to have a look at what's involved in doing that. So basically, if it has the 7 screws, that one cannot be repaired. But if it has the 4 connector screws, proceed to step 4, which means removing the FICM completely and disassembling the 2 halves. So we're going to see what's involved in buying just the circuit. So here's a picture of the fuel injection control module transformer, and my take on that is if we install just that part, which is the step-up transformer to 48 volts, no programming will be required, as opposed to changing the entire fuel injection control module. That is unprogrammed. So it's apparently available out of Winnipeg. So we're gonna talk this over with the customer and likely order one. So I noticed the ABS light is on and the TBC message on the dash. So other than the engine control codes, there's a problem with the left front wheel speed sensor, signal missing. Instrument cluster has ignition key in circuit fault. I noticed the key is not dinging, or the chime is not dinging. Low battery voltage at the module could be from just that, a low battery. Trailer brake control module message is on because of a brake pressure transducer sense circuit or trailer brake open circuit short to battery. Brake pedal switch code in the generic electronic module, the BCM. They seem to be okay right now. I checked the brake on-off switch input to the gen module BCM, and also the brake pressure switch input to the ECM seems to be good. It's got some parking aid problems. But the major problem is the FICM, so we're going to order that FICM control module repair kit and replace number 8 glow plug. I'm sure number 8 is one of the rear cylinders, but I'm not sure what side. I'll have to take a look at the cylinder layout. So number 8 is driver's side rear, so that one's going to get a glow plug. Hopefully can get at it through the wheel well. The truck looks like it's slightly lifted, so that might help. But nevertheless, that's where we're going with this. We'll order some parts up. So we're back. Today we have the fuel injection control module repair kit and a new glow plug for number 8 cylinder. This is static sensitive, so we've got to ground ourselves before we touch this and take it out of the package. So we're going to go ahead and remove the FICM from the truck and disassemble it as per these instructions here. So there's the FICM removed, and the instructions state that if you have the 7 terminals inside here under this little cover, you have to change the entire FICM. But if you have the 4 terminals, this service kit is supposed to work. So we have to remove these 4 T15 screws and several of the screws on the bottom of this cover. Now I noticed what appeared to be safety torques here. Didn't mention that. Yeah, T20. Well, let's get set up. So the instructions say to remove the 4 T15 screws, but mine are T7 from the under this little metal cover, and set them off to the side. I've grounded myself to the module prior to touching it. Now we're going to remove the screws on this side of the module, and I'll pick up when we get them all off. So once you get all the screws around the outside circumference, use a small screwdriver to pry up gently on the cover and remove the cover. Set it off to the side. Don't touch any of the electronics. So this is the component we're going after here. Now I'm going to ground the package to this before I open it. And try to handle this by the edge of the card. Okay, let's have a look at this thing. So this sits in here just like so. Okay, so we got to remove these 5 screws. 1, 2, 3, 4, 5. So next remove the 4 screws that hold the plastic covers on. Keep the screws with the covers and keep them in order. And then we've got to remove the torque screws that hold the module or the transformer to the actual top cover. Now I see these 2 are under this epoxy, so we're probably going to have to use a pick to dig the epoxy out. These are much shorter screws. I'm not worried about damaging this part because it's no good anyways. Yeah, I'm going to have to get a pick to pick through that epoxy. So once you remove the 2 plastic covers, you can remove the 7 screws. There's 1, 2, 3, 4, 5, 6, 7, and then you can take this board out, and this is what we're replacing. Now there are some heat transfer pads, that's those there, and we have new ones in the kit. I'm just going to read the instructions and see what they suggest to do with these heat transfer pads. It basically just says to remove and replace the heat transfer pads. Make sure to line up the holes, it says. Okay, I'm going to wash my hands. So the little heat transfer pads just sit in there. They only fit one way, just line up the holes and the screw holes. And now we're ready to install the board. So I'm going to handle it by the capacitors. Basically just like so. And then reinstall the screws. So there's the new circuit board installed. Put the plastic covers back on. Now I'm going to wipe off this gasket surface, and I'm going to put a very, very thin bead of RTV sealant on here just because I think it's a good idea. And then we're going to reinstall the other half. I'm going to clean off these 4 terminals with a piece of emery cloth just to make sure that they make a good connection on that board. But otherwise I'm not going to touch that circuit board. We're going to reassemble it and reinstall it in the truck. So there's the 2 halves reinstalled. I put a little bit of RTV sealant on this cover as well, just to enhance the seal on here. I think this is a T20 as well. And we're ready to reinstall it, but I'm going to see what access is like to that number 8 glow plug now that the FICM's out of the way, because reaching down from the top it might be easier with, definitely with the coolant degas bottle out of the way. it might be easier to access that number 8 glow plug, which is the back one on the driver's side. That's ready to go back in. I'm going to put a little bit of dielectric grease on the outside circumference of this seal to help slide in the connector and blow sand out of the connectors and reinstall it. So it is definitely easier to access from the top with the degas bottle pushed off to one side and the FICM out of the way. That's the very back glow plug. I've gotten it out. This top side creeper works really well, so I'm going to test it just to make sure that it's defective, but it's setting a fault code for it, so I imagine it's open. Well, I got a few acorns out of from around the bottom of the turbo. I don't think that's a good thing to have in there. I don't see any chewed wires. I did manage to get that glow plug installed. Let's put the FICM back in. Okay, so we're going to go into the engine now. And we're going to go into the codes menu and clear codes. And the wipers are on. The mist. And we're going to go into data display and have a look at FICM voltage. Should stay around 48 volts running. So it's 11.5 volts for power and 48.5 volts. So I'm going to cycle the key to get the glow plugs to cycle again, and I'm going to fire it up. Let's see what the voltage runs at. Okay, I'm going to start it up. Now it's holding at 48 volts now, which is good. Glow plugs must be cycling right now because it's only 10.5 volts. 11.5 volts. I'm not sure if this has got an intake heater or not. Well, we're going to run it up to temperature and then do a key on engine running test and a glow plug test. Make sure the glow plug's passed now. I think the glow plugs are still cycling, because that's why the voltage is low, 12.5. Or there's an intake, there may be an intake heater on this thing, and it's on right now because it's a cold start, or a cool start anyway. So what's important is we have a solid 48 volts from the FICM now, and not 32, 33 like we had before. So I'm going to run it up to temperature and then look at some more data. So it appears the FICM problem is cured, but the number 8 glow plug problem might not be cured. I've cleared the codes. Let's read them. No codes except the P1000. I'm going to do a key on engine off on demand self-test. That should run a self-test on the glow plugs. And we have no codes. Alright, well, I'm going to start it and do the glow plug monitor test. Let's do the key on engine running glow plug monitoring self-test. It's supposed to be 11 to 14 volts. This test cycles the glow plugs and monitors so it's resetting this number 8 glow plug circuit fault code. So there might be a problem with the wiring harness. There have been rodents in there. I didn't see any chewed wires, but there very well could be. There could also be a problem with the glow plug controller. So I did change the correct glow plug. Number 8 is the rear one on the driver's side. It's 2468 down the driver's side, 1357 down the passenger side. Let's look at the glow plug control module connector, and we'll do some tests right at the glow plug control module. So the green connector is for cylinders 1, 3, 5, and 7. So it's the black glow plug control module connector, and that services glow plugs 2, 4, 6, and 8. So it's pin 2. I might as well print this diagram. We'll have a look at this connector on the vehicle. So this finned aluminum module down here is the glow plug control module. The green connector feeds this bank, the black connector feeds the other bank. So I've got an ohm meter set up between the negative post of the battery, ground, and pin 7 right now, and it reads 0.4 ohms. So I'm going to set this up and we'll go through them. So here's the connector face view. So pin 2 goes to glow plug number 8, and it's a red wire, and 1 goes to glow plug number 6, and 6 and 7 go to glow plugs number 2 and 4. So common sense says they should all measure the same. Right now I'm on pin 7 and it reads 0.41. I'm going to move it to pin 6. Wait for the meter to 0.4. I'm going to move it to pin cylinder number 6. Starting to see a pattern. Now I'm going to go to glow plug number 8. Why is it double the resistance? Almost double. Well, actually it is double. 0.4 and 1 ohm. So there is a connector in between here. So I'm going to monitor this resistance while I manipulate that connector. I think the connector's under the air induction pipe over there. It could be compromised, could be corroded. Now, is that enough to make a difference? I mean, we can compare all the other glow plugs as well on the other connector just the same way, but I'm sure that 0.4 is what we're shooting for. So this is the connector going to the glow plug harness that runs down the left side of the engine. So we're going to manipulate this connector while we watch the resistance. Okay, I'm wiggling the connector. No change. Well, let's take it apart and check it from here. I'm gonna get a screwdriver to take that apart. There's a secondary lock on it. Now I did measure the resistance of that new glow plug, and I believe it was 0.9. So you can see it went open now. So I'm going to check it from here and see what it measures. So I'm at the face of this connector now, going down to the side here, and it reads 0.46 on number 2, 0.46 on number 4, 0.46 on number 6, and 1 ohm on number 8. I'm gonna try and reach down there and manipulate that connector. Doesn't change. So is there a problem with this harness, or is that glow plug actually too high a resistance? I did measure it prior to putting it in, and it was around 0.9 if I recall. There's the original one. I'm going to load test that circuit and see how it works. So I've got a headlight connected across the battery positive, and if I put it on each glow plug, it lights up a headlight quite well. Now it's possible that the resistance of that new glow plug is a little higher than the factory ones. So I think we have a problem with the glow plug control module. Even though that glow plug is higher resistance, the circuit tests okay. I'm pretty sure it's the glow plug control module. Only way we're going to know for sure is to replace it. Now I suppose I could swap number 8 glow plug with another cylinder just to be sure, but I don't think that's going to be done because it's not that convenient to take them in and out. Connectors can be a pain to get off. Let's see what a glow plug control module costs. So here's my thought process. Rather than switching the glow plugs, I switched the 2 wires in the plugs. So it's just a matter of depinning the wire. So this blue wire is actually number 8, and the white wire I believe is number 6, but it's one of the other cylinders regardless. So I've switched it now. We're going to reconnect it. We're going to run the self-test and see if it still sets glow plug number 8 code. If it does, then it's a problem with the actual glow plug controller. If it sets a different glow plug, number 6 for instance, then it would be a problem with the wiring harness or the actual glow plug. So I got it on pin number 1 now, and it reads 1.19 ohms, and pin 1 is glow plug number 6. Pin 2 is glow plug number 8. So if my theory is correct and it's a glow plug controller, it's still going to set the glow plug number 8 fault code. If it's a wiring problem or a problem with the glow plug, it should set glow plug number 6 code. Even though there's over double the resistance here, I still think that that's an okay measurement personally. Okay, so I've managed to clear the codes. Now I'm going to do the glow plug self-test again. And if my theory is correct, it's going to set the same fault code for glow plug number 8. I suspect the drive transistor that's inside the glow plug control module has failed. Ta-da! Okay, so this thing's getting a glow plug control module. And I'll switch those 2 wires around so it doesn't confuse somebody with the cylinder numbering after. So we have a new glow plug controller here, and we're going to mount it in place, install it, reconnect those glow plug wires in the correct order, and rerun the tests and see how it fares. So there's the new glow plug control module installed, the 2 connectors plugged in, dielectric grease on the connectors. You can get it in there with a little bit of finagling. Rerouted those 2 wires and that connector underneath that one up there, right in the center of the screen. I reconnected, switched number 6 and number 8, and now we're going to cycle the key, scan it for codes, and see how it fares. Okay, so I'm going to go into the engine control computer here, codes menu, clear codes, say yes, continue, and the code should be cleared. Now the only code it should have is a P1000. Great. Okay, so we're going to fire it up and run the glow plug test again. I notice it's running much smoother on a cool start. Mind you, it is warm in the shop. Now this test is supposed to be done. Actually, I should wait for the glow plugs to stop cycling because I'm sure they're cycling still. You'll be able to tell by the system voltage. Supposed to run that glow plug test once it's hot or once it's warm anyways. FICM power is only 11.5 volts, 10.5 volts, so the glow plugs are still on even though it's started and running. So we'll wait for this to stabilize. Alright, let's run that glow plug test. functional tests, injection control pressure duty cycle, glow plug monitoring cell test. We'll see if it'll run this test, and hopefully it passes. The test takes about 60 seconds to run. No code, yay! So it definitely needed a glow plug controller. Well, that's it. Go back in and have one last look at our FICM voltage. Should be 48 volts while it's running. It's over on this side. FICM voltage 48.5. Nice and stable. So we'll call this one fixed. Thanks for watching.